Welcome to August Leetcode Challenge. Today's problem is stream of characters. Implement the stream checker class as follows. We have a constructor which is going to initiate data structure with a list of given words. Then we want to write a function that's going to query a single letter and return true if and only if the stream of characters that we've been inputting so far from order of oldest to newest includes the word that just got queried. So we return true as soon as we hit the end of the word. You can imagine that if we had a list like CDFKL, as soon as we enter CD, that's going to return true. If we did CCCA and then D, that's going to return false because it's like the stream of letters need to equal the word. So they give us a hint telling us to implement a tree, and we want to manage a set of pointers that's going to, I guess, point to the node that we are inside of this tree. So that's going to indicate to us when we've reached the end of the word. So let's start off by writing out a tree. The way I usually like to do that is to create a nested dictionary. You could have a different class of a tree and tree nodes, but I don't think it's really necessary. Let's just initiate all these words into a tree. So for each word in words and for each character inside of the word, we are going to start off with our current pointer pointing to the root of the tree. So that's going to be self.tree, and we'll say, hey, if this letter is not in cur, let's input that, and that's going to just be cur.l is going to be equal to an empty dictionary. After that, we'll just increase our pointer to say point to the dictionary that's inside of this key, and that's it. Just return, continue that forward, and that's going to initiate a tree. Now at the end of the word, we want to have some sort of character that's going to indicate this is the end of the word, and I usually like to use a hash function to do that. To do that, we'll just say, okay, just make the end of the cur equal to hash, have a key for that, and this could be equal to anything. I'll make it equal to true. Alright, after that we want to have some sort of data structure that's going to be our set of pointers, and I'll call that, let's call that stream, and we'll make it a queue. And I'll go into why we need to make that a queue in a bit. Let's first print out our tree and just see what it looks like here. Okay, so we've entered in our list of words. You can see C is our root, and then we'll have D being a nested dictionary, and that's going to indicate to us end of the word because we do have CD, we have F, we also have K going down the path L as well. Oh, great, so that looks good. Now how do we want to query this? Now this is where it gets tricky, but say that we want to know where we are so far in our stream. But there's a problem here, because say that we have the word A, B, C, D, and we have the, it's not an example. Let's say we had the word, how about A, B, C, A, B, right? Well, when we're at A, are we at A, the root of A, B, C, D, A, B, or are we at A, the fourth character, A, B, C, A, that point? We don't know. So that's actually going to be a problem. We have to make sure that we are pointing to both of those A's to know that where are we inside of our stream. Really, at this point, like, our stream could be going down one path for the words, or it might be at another path, or it might be at the root. We might have to start it over, and because there's no paths that exist for this letter except at the root, so we'd have to just get rid of everything else because those streams don't matter anymore. I hope I'm explaining that okay. All right, so what I'm going to do is initiate a temp queue, and I'm going to add to our stream also the root and the tree. And the reason for that is we might start over our whole path. Like, there may not be any more paths for this next letter, so we have to check at the root as well. So for each, let's call it P in self.stream, what are we going to do? well, basically we want to check to see if it exists the key exists inside of this point, right? So if P, or I should say if letter in P, well then we want to append to our temp queue the nested dictionary. Otherwise we just continue, and that should be it. At this point we'll have a bunch of pointers, or maybe just one inside of our temp. We should reinitiate our self stream to equal the temp. And then we'll just check, hey, for all of our pointers in self.stream, do any of them have a hash inside? So if hash in P, then return a true. Otherwise, return a false. So this is kind of the straightforward method using a tree. Let's see if I've forgotten anything here. And it looks like it's the same. False, false, true, false, true. Let's go ahead and submit that. And as far as time complexity goes, I believe this would be, let's see, the number of words times the length of the words. But this has a problem, and the problem is it's very slow. It's not optimized at all. And the reason for that, if you start thinking about it, is really tricky to explain. I wish I had my whiteboard to really go into it deeply, but say that we had like all these words, and we're doing a bunch of, like, say that we had the word ABC inside, and we're constantly passing in AB, 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 and it's just checking each time, going through this path of AB, AB continuously. If you think about that carefully, that's a lot of wasted work, because we know we're not at the end of the word. Like, the only time we care to see are we at the end of the word is if we've been given the last letter inside of our words. So what if we actually reversed our tree? We started it with the last character all the way to the first character, and then indicate the end of the word at the end of the first character. What that would allow us to do is not go through all this extra work. We'd only check to see if our stream has our letter when we've reached the last letter. And that saves us a ton of time here. So to do that, it's not that complicated. We would just reverse our words. I would still go through every word, but it would reverse it. So now the last character is going to be the first inside of our tree. This would all still stay the same. And we still need some sort of stream to indicate to us like our past queries. So instead of having this temp queue, what we'll do is add our, how about the letters that we're querying into our stream. And we'll append it to the left because, well, we'd be going backwards, right? We have to get the last character and then we go backwards. And depending on whether we've been able to form a path or not, we can break as soon as we find that there is no path, or return a true if we find that there is indeed the end of the word, or it's like the start of the word. It's the same thing here. Okay, so for P in self.stream, that's still the same. We'll check to see if our letter is in P, and if it is, we want to increase our pointer. So maybe P is not the best word. We'll say L for letter. And we'll have some sort of current pointer. We'll say current pointer is, well, right now, I'm going to be pointing to the root, right? And if letter in, or I should say if L is inside of our cur, then we want to increase it. Say cur equals cur letter. Otherwise, break, because there's no path. We can just stop our work, like Y, continue. And finally, we also want to check to see if there is a hash. If there's a hash inside of our cur, then return true. Otherwise, if we get through this whole loop, we'll return false. So this actually ends up being much faster. Let's see if I've forgotten anything. And there we go. Make sure that's much faster, and it is. It's about, I don't know, 10x faster. And this ends up being, I apologize, I don't remember the time complexity, but I believe it was the O of n times k, I believe. K, which is going to be maximum length of the words. Okay, so hopefully I've explained it okay. This reversed tree is not very intuitive. It didn't come naturally to me. I had to look it up. But once you kind of get the idea of how we have to have these pointers and what's going to indicate to us like the end of the word, I think it starts to become more understandable. I would recommend going into it more to truly understand it. And yeah, I think that's probably going to be it for today. So thanks for watching my channel. And remember, do not trust me. I know nothing.